Hello, this is Acid Base 104, and what we're talking about today are strong and weak bases. And there is an optional assignment out of chapter 16, and the required AP assignment is still just the Acid Base 4 worksheet, which will go up on Canvas today. It's Wednesday, the 22nd, I think. Okay, so part 1 is about strong versus weak bases. And we're going to just go back to really quick the definition. The Bronsted-Lowry definition of a base is a hydrogen acceptor or a proton acceptor. Another way to look at this is, therefore, it's a substance that increases the hydroxide concentration of a solution. A base increases the concentration of hydroxide in a solution that's aqueous, because often it will take the hydrogen from the water. Okay, so there's two kinds of bases. One is a strong base, and the other is a weak base. And strong bases are substances that bring hydroxide with them into the solution that are soluble. So these are any soluble hydroxide compounds. So like potassium hydroxide, sodium hydroxide, let's see what else, calcium hydroxide, lithium hydroxide. So you can see all of these bring hydroxide with them into the solution. So you can say here that the base concentration for a strong base is equal to the concentration of the hydroxide. And that's only when one hydroxide is in the formula. So we want to remember that for potassium hydroxide, sodium hydroxide, and lithium hydroxide, this is legitimate. For a substance like calcium hydroxide, if we want to know the concentration of the hydroxide, so that's one point. Second point is if there are two hydroxides in the formula, you double the concentration of the base to get the concentration of the hydroxide. So because there's two hydroxides in each formula, like calcium hydroxide would have twice the concentration of hydroxide that the actual base has. Okay, so with these ones, with substances like this, we want to remember that pH plus pOH equals 14, and we are able to calculate pH of a solution based on the concentration of the hydroxide. So let's say that we want to know, for example, what is the pH of a solution with concentration of calcium hydroxide equal to 0.250 molar? Question mark. Okay, so in order to find the concentration of the hydroxide, which we'll need to get to the pH, we're going to take, we know that for every calcium hydroxide, for every one calcium hydroxide, there are two hydroxides, okay? So that makes this concentration 0.500 molar in hydroxide, because there's 2 for every 1. If we negative log that, 0.500, where's my calculator? Here it is. Negative log 0.5, and that gives us 0.301, and that's going to be equal to our POH, and then 14 minus that number gives us 13.690 for our pH. So this is a very basic solution. Okay, so those are strong bases, and we'll do a couple more example problems in part 2. And our weak bases, these are substances that react with water by taking a hydrogen from it, and that produces hydroxide. So for example, or kind of a general formula, I'm going to make a line here. Kind of a general formula for a base, any weak base that's aqueous plus water, liquid, would be in equilibrium. That's an equilibrium, it looks kind of weird, but an equilibrium with one of these hydrogens is going to go onto this base. And since the hydrogen has a positive charge, then we're going to have BH plus. So we form a new polyatomic cation, and that will be aqueous plus hydroxide, aqueous. Okay, so the hydrogen is transferred from the water to the base, and that makes BH plus, and this is called a protonated base. So it makes BH plus, and what's left over of the water after the hydrogen is gone is hydroxide. Okay, so we'll stop there with part 1. We'll do another calculation, or we'll do a calculation example in part 2. Thank you.